Hello, this is Connor Bosch, and here is my methodological search of area circuit. So I have a switch here, which is actually supposed to be TCRT5000, the color sensor. And it's basically just set as a switch, so in my code I can have a digital write, which is a 1 or a 0, and whatever side this switch is on, it's going to be either a 1 or a 0, which is going to help me out with my code just to so I understand how the color sensor will work. In my real circuit, I'm going to use an analog read for my TCRT5000 to make it easier to see colors. So I have the positive connected to the positive terminal here, the 3.3 volts. I have it connected to ground, and I have the middle going straight to A0 on the Arduino. I have the cathode of the LED going straight to a 220 ohm resistor, which is going to ground, and the anode of the LED is going up to D12 in the ArduinoUNO. Then on my H bridge here, I have the VCC1 connected to the VCC2, which are both connected to the V in here. So yeah, I have it connected to the V in there. I have both sides connected to ground, and then I have my input here. I have my first input here connected to D2, and then I have the two outputs here connected to my motors, and my second input here, which is going to 3, and then my enable pin, which is going to D7 there. Here is my enable pin on the second motor, D6, and then my input pin for the second motor is going to D5, and then the output wires here connected to the motors, and then the input there again at D4. So I'll go into the code now. So I've defined all my pins, same as usual. I just define them, just helps me out when I'm transferring the code onto Arduino IDE, which is for the real circuit. So in my void setup here, I have serial begin at 9600 bits per second. I have all my pin modes here set up, motor A1 output, motor A2 output, the motor speed output, and it's the same for the second motor. I have my red LED here, which is an output, and the infrared is an input. And then I have analog write to my two motors just to set the speed. So I have two voids here, which is one void is forward, so the forward motion for the motor for the mini robot. This is just the LED will be low, and the motors will drive forward. And then I have a rotate, which is the LED will be on, and one of the motors will be going the opposite direction to rotate the car. So I have black white set as an integer value, and then I have black white equals digital read infrared. So this is what I was saying earlier. I have it set as a digital read. So whatever value this reads is going to be a 1 or a 0. Either the left side of the switch or the right side of the switch, which will determine what void to use in here in the loop. So it goes if black and white is equal to 1, then rotate. If else, go forward. So on the serial monitor down here, if I start simulation here and it says 1, then we know that's going to rotate. So the LED will be on, and one of the motors will be going. The motors will be going the opposite direction. And if the serial monitor sees a value of 0, then the two motors will be going forward. So I'll show that now. So, okay, I got the serial monitor up. So at the moment we're seeing a 0, which means we are going forward at the moment. So both of the motors are going at minus 10,000 RPM. So they're going in the same direction, so that's what we want, and the LED is off. So it's going in a forward motion now. And now once I click this switch, then you see one of the motors goes to positive 10,000, and the LED is turned on. And here it says 1 in the serial monitor. So in theory, the mini robot now is turning as it sees 1. So it's seeing 1, and while it's seeing 1, it's going to turn. And then when it goes back to seeing 0, then both the motors will go forward. So I'm going to set a delay onto my real robot just to allow it to have time to turn away from the black and then to go forward.